This is the fourth video in a series about solving logs and log equations and exponential equations. In this video, I'm going to cover examples 5 and 6. So for example 5, part A, hopefully you recognize this as pretty easy by now. Recall that the natural log is base E, and we can just use the definition of logs. The base raised to this power equals x. So we have e to the third equals x. That is the exact answer. I can then use my CAS in order to find the approximated value, just so you know where it is. On your CAS, on this button here with the library book on it, if you hit Control and then the library book, it brings you up a menu of values, and E is just the second one. So you can hit enter, and then we can raise it to the third power, and if you hit Control enter, it'll give you your answer, and we would round it to 3 decimal places, so our answer ends up being 20.086. All right, for example B, we've got a log with base 3 on one side and a log of base 3 on the other side. So in this case, we should hopefully remember our one-to-one property. Since they have the same base, I can actually just ignore the log part and just say x plus 2 equals 4x minus 19, and go ahead and solve that. So I'll subtract x, add 19, I get 21 equals 3x, which means x equals 7. For example C, hopefully you remember your log laws. If I can combine this part of the equation into one log, so I'm going to condense it into one log, then I can use the inverse property to take the log of both sides, or I could use the definition of a log in order to solve it. So let me start by rewriting this as one log. When logs are subtracted, that means division. So this is log base 6 of 3x plus 14 divided by 5. And all of that is equal to 2. Be careful here that you've written it in this way. The parts of the log that are in the parentheses, those are the things that are getting divided. It's not the same as log base 6 of 3x plus 14 divided by log base 6 of 5. So like it's just one fraction with one log, not 2 logs in a fraction. Those are different things. Okay, so now that I have one log equals a number, I'm just going to use a definition of logs. So 6 raised to the second power is going to equal this thing. So 6 squared equals 3x plus 14 all divided by 5. I can square the 36, and then I'll multiply by 5 on both sides. Or sorry, square the 6. So 36 equals 3x plus 14 divided by 5. Multiply by 5 on both sides to get rid of that. 180 equals 3x plus 14. Subtract 14 and then divide by 3. So if you subtract 14, you get 166. Divide by 3. And that's the exact answer. Or I can use my CAS and I get 18.444. It's wise to then actually use your CAS to check and use the exact value. Here, if I plug the exact value in to the expression, I should get 2 as my answer. For example 6, we're going to solve each log equation and round to 3 decimal places. I'm going to start by isolating the log. So I'm going to subtract 5 from both sides. 2 natural log of x equals -1. I'm going to divide by 2. Natural log of x equals -1/2. I'm going to use the definition of a log. So this is e to the negative 1/2 equals x. That's my exact answer. Or I put it in my CAS using that little E button, and I get 0.607. For part B, try it on your own maybe first. Subtract 6 to both sides. Divide by 3. Use the definition of a log. So this is base E. So E to the negative 2/3 power is going to equal x. Use your CAS to figure out what that is. X equals 0.513.